a short form name for that. So a lot of this, what we see is that there's a lot of sometimes copies of documents, data, things like that, right? And then we want to be able to really manage participants who are coming in to this blockchain. You know, what is their access, what is their identity, what is their authorization, and things like that. And that's when you need a consensus, just like you're having a meeting. You know, how can you have a consensus before you then come up with the next permission set and things like that. So distributed ledger framework, gives you that framework. It gives you that framework so that you can build upon it. So a lot of people build applications. So this concept of buyers and sellers, you're connecting buyers and sellers, right? So, and who is really the person? Really, if the person who's starting that concept in that distributed ledger could be the market manager. Now he would want to have some kind of governance or some kind of rule-based permission. So with that governance and rule-based permission, he can actually inject it so that other people who are requesting it, it actually is related to them as well. And then, other peers that you're connecting, channels and so forth, can propagate that identity downstream, right? So you have the identity context essentially. So that every person can have a copy of that ledger going forward, right? So that's what we call the identity exchange, essentially. So here's a very basic explanation of what a blockchain market application is. You can think of the market as just about anything. You are creating an application in a market for the purposes of digital identity or even the purposes of supply chain management, anything, even food. Nowadays, people are also looking at it from pork to all the way from the source of the food and things like that. So anything that has challenges of that sort. So each participant will manage their own set of blockchain servers, right? So one will have their own set of blockchain servers. Then when you submit the order, it goes into the pending verification state, and they are sent to multiple participants essentially. So typically, this can be distributed across like multiple countries. You can have an East Coast a buyer, somebody in China as a seller, and servers in each one of these. So each person can have like their own blockchain and so forth. Nowadays, a lot of people start asking questions. For example, I'm in Singapore. There's a fintech festival there. So how do you interoperate between blockchains? Right, one has their own setup, another person has their own setup, and things like that. So since there's no central database, obviously, that's the concept of it, right? So of course, that's really part of it and things like that. So here's a basic market application. Now, how do we actually implement this? Usually, from an Oracle standpoint, we've chosen the Hyperledger framework, right? So Hyperledger has the benefits of it, obviously, is that it's open source based, so there's visibility by everybody. Everybody can see it, what is really happening. So then people can use their own technology stack and build on top of some of these applications. It's also powered by the Linux Foundation, and Oracle is a member of the Linux Foundation, and also the Hyperledger consortium and so forth. In fact, Oracle is also part of the our blockchain as a service is built on top of this. And at the same time, if you're implementing technologies on any containers below that, things like Docker, Kubernetes, and so forth, most likely today, all developers build on these kind of technologies. So even that container native technology, framework consortium we're actually part of. So the key thing is that leveraging that and providing that right support. So the security challenge in these kind of distributed applications that we typically see is who is managing the message of these registered participants when it's going from one PCS to another, right? How do you ensure these authorized messages actually contain that specific authorization token and so forth, right? If you want to add new attributes to that, you want to be able to send additional verification, right? So this fabric that we call it a fabric, interconnected fabric, right, becomes a reference architecture in that sense. So the market manager has these root certificates, which we heard of just now, and you're issuing these certificates and things like that. But then there are a lot of open questions left. What happens to the authorization, the fine-grained authorization? So a lot of proposals today on using custom chain codes and implementing a lot of these controls, but it becomes very difficult to maintain when you're working with a large sort of organization that's again working with a lot of other markets, buyers and sellers and things like that. So with the Oracle Identity Cloud Services and also identity management in essence and so forth, the goal is to create this kind of encompassing framework that blockchain applications can really use from a distributed identity exchange perspective. So it's modern in the sense that you can secure that. You can start using standards like SAML. SAML is like a federation language, federation standards. You can connect between applications. Also, you can start looking at things like OpenID Connect, SCIM, which is SCIM, and all these are basically what you call federation authorization standards that application developers today use. So we want to be able to make it automatically available so that it can be triggered quite quickly. So we are investigating and also investing a lot in having this made ready as part of the blockchain. So as our blockchain as a service is made ready, we're not just going to make it ready just as a raw entity by itself. We're going to have pre-built identity cloud services in there so that organizations can use for their existing identity users. They can add new groups, permissions, add roles, so that they can actually manage this, right? They eliminate the need for multiple silos, because when we started, to be honest, I'm from Singapore, we're one of the first adopters in the world of PKI. PKI, although it's very good from a certificate authority perspective, it becomes very hard for it to be distributed, to be exchanged. So for example, military to military, defense to defense, different countries and so forth, it becomes very hardened piece. And so we want to be able to take that. Of course, that's a good standard, and a lot of people have started doing that. But we want to be able to also add things like authorization capabilities, like modern OAuth models. These are ways of giving obligations. For example, when you sign on to particular applications, they give you an authority to sign on your behalf, but then they allow you to request permission from you. So these are what you call obligations, constraints that are bundled into that authorization token. So then you can define the scope for who, when, how, to what extent, what limit, and so forth, right? In terms of transactions and things like that. So that way, what happens is that old application that you saw there, which was of course using distributed ledger, now from the infrastructure, you have created on that red box there, you can manage this registration of buyers better, right? You can do federation between different types of servers. You can manage authorization tokens also. So this way, the identity service becomes like an interceptor, like a guiding principle, right? So that it provides that additional access control that is needed to verify this. So this is something that is, it becomes part of that market application that extends it, right? So now the buyers, the orders, and the sellers, the market manager has much more visibility and control in terms of being able to look at it end to end. So moving on that notion of digital identities, right? How can we use this notion of how we have introduced additional verification, additional authorization, additional into the market application? So a lot of physical and digital identities, right? So you have a driving license identity, your passports, and your bank credit cards and things like that. Average person has over like 27 types of digital identities, right? So that's a survey done in 2016. So you can think about it today that you already have a lot. You think about loyalty points and things like that. So can you imagine if there was a digital identity, right, where you have a collection of these attributes that cannot be changed, like your like your social security number, your driving record, things like you want to be able to unlock so that you can, wherever you're going, it's accepted as part of the organization. So a lot of these identity proofing techniques can be enabled. So the problem for the users is really three. So the privacy concerns, right? Wherever the users go, that particular service online, whether it's connected or disconnected, it needs to be able to manage what the person is allowed to share about themselves. And also the inability to revoke access. You want to revoke your access, you want to remove the privilege, you want to be able to say, for example, data protection laws that are coming up quite a bit now in every country in Asia. Every country has a data protection law, right? Obviously, the largest ones that we are seeing is the EU one, which is called GDPR as a standard. So you want to be able to have these kind of capabilities where you can have predefined federation for boundaries, right? Cross-jurisdictional country boundaries. Since every country is going to have their own anyway, and we already anticipate that. So how can we have these regulated from a application owner and identity federation perspective, right? What entities someone can see. If you want to single sign on to one aspect, you then want to be able to single sign on to another, but you want to respect these boundaries and things like that. How can you mitigate these trust relationships and so forth? So the problem, that becomes a problem or challenge for these application owners who have been maintaining this. So new privacy laws, consuming identity from one authority to another, Identity is also a cost center. You have to maintain that within the company, right? You have to constantly upgrade that. Then identity proofing. Who do you trust? Who's that third party who's going to be trusted? And how do you verify that trusted person? Indeed, right? So that becomes expensive and time consuming. So wouldn't it be great, right? And this is where Oracle is coming from a perspective to say, wouldn't it be great in a market to have a distributed identity exchange framework, right? Or a distributed identity exchange capability that allows identity artifacts, all these kind of attributes, relationships, to be securely exchanged between authorities and also the consumers, so that you can constantly able to communicate and also share that information. So you verify a large number of these identities that are coming in, for example, both sides of the exchange, right? You get a better privacy. You can then also cache them locally. Say, for example, you have something, defense, military, government installations, want to just run it locally in one place, so you can cache it, say, for that particular piece. So that's where, when we see that emergence of blockchain technology coupled with that kind of capability, it helps in the decentralized model. That transactional thing becomes more predictable, right? And at the same time, you are able to then share all these kind of things between the different areas. So what happens now? Say, first thing, you have implemented it, you've got the application developers and all. So now a person is going, first time using this distributed identity exchange. So he opens up a banking website, and he clicks open an account, register an account, and things like that, number one, right? So the bank redirects to this distributed identity exchange that has our blockchain capability, blockchain service capability already deployed. So then asks them, you select like an identity selector, right? And then from that choice, it will then be able to negotiate with others to check on your behalf, verification and so forth. So you pick up your mobile carrier, then that gives that verifiable consent that really you want to release this identity data for that particular request and so forth. And then it constructs automatically behind the scenes code and data specifically for that type of usage. And then finally the bank uses that code contract, and then you're able to then look at it and secure that ledger going forward. So this is how you will interface with that identity exchange, right? That distributed identity exchange. Who is using it today in terms of the identity space? So there are a couple of different types of use cases. There's initiatives going on in Canada that we are working with. Oracle is working with quite a few of the partners in the region and so forth, where we have the concept is federated identity exchange as part of our blockchain cloud services. And at the same time, we've seen a lot in healthcare and also in government login in terms of replacing those legacy type architectures and so forth. And several other initiatives are going on in North America, Dubai and so forth, and also in Singapore. We're beginning to see that a lot of the older standards, just based on, say, things like Active Directory, PKI and so forth, they really need to be able to expand and leverage modern applications that come on board very quickly. The applications are already ready with a lot of new services and all, so it has to be robust and be able to support that. So the attribute exchange that happens in this identity exchange now, as we add it for that additional capability and so forth, is that, say, for example, you have a third party or a relying party, the trust party that you want. So they will say what they want to be satisfied with, your nationality, your age, you're 21, you are of this residency, of this state, and how long you've been. And then it redirects to the identity exchange. And finally, since they have specific attributes that you have confirmed and you have released, then they will allow that service to proceed and so forth. So here you have interactions between every single layer. There is no bypassing of that and so forth, right? So the service and the identity exchange and all that is decoupled. So that way, you have that, ability that you have been able to implement, and you have end-to-end understanding of what really has been done. So what we're really saying from an Oracle standpoint is that having this distributed identity exchange as part of your Oracle, as part of a blockchain as a service, gives you that unparalleled end-to-end, ability to bridge that market, where you have your market manager, he wants to implement governance rules and things like that, and you can bridge that gap between the buyers and the sellers, right? You don't have to work in silos, right? In that whole landscape of, I have to issue you a particular key, a certificate and all that. It doesn't scale. You need a framework that will scale, that can grow fast, that can communicate with other types of blockchain networks as well, and that respects the application developers because they develop really fast as well. And also their authentication principles and so forth. So having the identity context together with that really gives you that end-to-end capability. In summary, what we would say is that having a mindset of a identity security operations is very, very important. Because let's face it, when you're developing an application, you're consuming a blockchain as a service. You're also developing the application. There will be vulnerabilities there as well. So you need to look at the identity context in exchange perspective, single sign-on, authentication, authorization, but more importantly, you need to have a mindset of what happens first, right? In terms of prediction, what could happen, what might happen, right? If there was some vulnerabilities in there. So like what you have, you need to know what you have completely, not just the blockchain application, what asset you have. Then you need to be able to know how to prevent any of these threats that happen. What kind of detection parameters you have in place, and how do you respond to that? And how do you do that? You need to have complete understanding of your landscape, from the identity context, the exchange and so forth, cloud activity, if there's any, and you're subscribing to third party. Also on-premise, meaning whatever you have in terms of your local servers, whatever you implemented there, and assets. Assets meaning not just physical servers and things like that, but also the data in there. So the protection should be as close as possible to that data, right? So key here is that from that conceptual understanding, we are able to then power our existing framework and how we want to move towards that, blockchain as a service, coupled with compliance requirements, and this is where it gives you that flexibility to look at it from an identity security operations center and so forth. So that's pretty much what I wanted to really cover from the different aspects of it. And since I think we still have a couple of minutes, I can take some questions on different areas, on applications, also on some of the use cases that were covered, and also some of the security elements and things like that. I've left out some of the threat elements on how threats are coming in. I can always do that as an offline conversation. Today was more about really looking at use cases and working with the rest of the team to show you how you can use this and how you can scale for commercial and enterprise requirements and so forth. Please. Yeah. I think we still have like 10 minutes.